Hi everyone, my name is Gajan, and today I am presenting my Capstone project from Module 2, which is EDA, Exploratory Data Analysis on Amazon Prime dataset. So the goal of this project was to understand the content style of Amazon Prime, which has a library of over 9,000 titles. So knowing what to release and when is critical for customer retention. So my business objective was to analyze this data to identify trends in content types, um, genre popularity, and audience preferences to help stakeholders make the data-driven decisions for future content acquisition. So I wanted to answer questions like, is Amazon focusing on movies or TV shows? Which genres are dominating? And is the content actually growing or has it stagnated? So to do this, I first set up an environment. So I started by importing necessary libraries. I'm using pandas and numpy to handle dataset and matplotlib and c1 to generate charts. So I also set c1 style to Edgar to ensure my final chart look professional and readable. So then I loaded two datasets using pd.read underscore csv. So first is title.csv. So this holds all the metadata like release year, runtime, and IMDb scores. Next is credit.csv. So this contains the cast and director information, which will I use later for talent analysis. So next step is initial data inspection. So before performing any analysis, it is critical to understand the data structure. So I used the .info method to inspect df titles data frame. So this output tells me a lot. First we have 9,871 entries. Second is we can see the data types which are correct mostly, but there are significant null values in the seasons column and age certification column. So and finally, if you look at the genres column, uh, it is listed as an object and which is a red flag. So it suggests that genres are stored as text strings rather than lists, which will require a specific feature engineering later. Uh, so next step is data cleaning. So data cleaning was first major step. So I noticed that over 8,000 rows had null values for seasons. So in this context, null value isn't missing data. It implies the title is a movie, which naturally has no seasons. So to fix this, I use dot fill no method. This replaces the nulls with integers, which is zero. So this is crucial because it allows me to perform numerical analysis on the column without errors. And for age certification column, dropping the rows would result in significant data loss. So instead, I imputed this missing values with category, which is not rated. So this keeps the data set intact while accurately labeling the unknown data. So next step is feature engineering. So now this was the most technical challenge for the project. So in this raw file, genres are stored as strings that look like lists. For example, comedy, drama, which are inside list. So you cannot analyze a string like that directly. So to solve this, I imported the AST library, which stands for abstract syntax tree. So I wrote a custom function called safe underscore literal underscore eval that uses AST to safely parse that text string and convert it into a functional Python list. However, a movie can have multiple genres. To count them accurately, I use the pandas dot explode function on the new genre list. Uh, what dot explode does is it takes a single row with a list of genres, say comedy and drama, and split it into two separate rows. This uh, transformation is vital because it allowed me to create a new data frame, which is DF genres exploded. So where I could finally perform a frequency count on every specific genre. So coming to visualization part. So first is content type, movie versus TV show. So with the dataset process, I moved to visualization, and my first question was, what is the platform's focus? So I used value counts on the type column and visualize it with a pie chart. And the results are clear here. About 86.3% of Amazon Prime library consists of movies, with only 13.7 being TV shows. And the inside here is that Amazon Prime positions itself fundamentally different from Netflix. It is a massive movie repository and not a binge watching TV series platform. Second visualization is top genres. So I wanted to understand the content diversity. So using the DF genre I exploded a data frame I engineered earlier, I counted the values and plotted the top 15 genres. So here you can see that drama is the overwhelming leader, followed by comedy and thriller. So the inside is, if you look at the bottom of list, science fiction and animation are very low. These are high engagement genres with loyal fan bases. So this data reveals a potential content gap where Amazon is under investing compared to market demand. So third visualization is content evolution over time. So I look at the temporal trends when Amazon acquired this library. So I grouped the data by release year and filter for titles before 1982. Keep the visualization relevant. So this line chart shows a massive exponential spike starting in 2015. So the inside here is this correlates perfectly with the global streaming wars. It provides data-driven proof of Amazon's strategy to aggressively acquire volume between 2015 and 2020 to compete for market share. So next visualization is ratings correlation, IMDb and TMDB. So here to validate quality ratings, I look at the correlation between two different platforms. First is IMDb, second is TMDB. So I first drop rows where scores were missing to ensure clean data. Then I calculate Pearson correlation coefficient, which resulted zero point 0.8, sorry, 0.58. So and I visualize this using a scatter plot with a red regression line. So the inside here is that there is a upward trend which confirms that quality perception is generally consistent across platforms. So if a movie is good on IMDb, it's usually good on TMDB also. However, the spread of dots shows there is still significant variation in user opinion. Next visualization is IMDb score distribution. So, uh, so I analyze the overall quality of a library using histogram of IMDb scores, and the red dotted line represent the mean score, which is 5.98. So inside is the distribution forms a perfect bell curve centered on average 6 by 10. This indicates a quantity or a quality problem. So this library is diluted with mediocre content, and there is lack of high density content in the excellent range of 8 and above. And then there is talent analysis, which is actors and directors. So I wanted to understand the talent driving the platform. So this required a complex merge of our titles and credits dataset. So I filter the data to separate actors and directors and plotted the top 10 most frequent names for each. And the results were surprising because the most prolific actor aren't modern A-listers, but the classic stars like George Gabby Hayes. S- So this reinforces the insight that Amazon's volume strategy relies heavily on licensing deep catalogs of classical older films rather than just producing new originals. So finally, coming to the conclusion. So to summarize our findings, this analysis has revealed five distinct characteristics of Amazon Prime Video Library. So first, it is a movie-focused library. So our data showed that the platform is heavily skewed towards feature films, which make up to 86.3% of the content, compared to only 13.7% of TV shows. Second is drama is the dominant genre. So the bar chart clearly identified that drama is the most common genre by very wide margin. Nearly 5,000 titles are a drama, followed by comedy and thriller. Third is the content quality is average. So as we saw in the histogram, the average IMDb score is 5.98. So the data forms a classical bell curve. So which indicates that most of the content is rated as average. So with no significant skew towards exponentially high quality titles. Fourth was we saw aggressive library expansion. So our timeline revealed a massive exponential increase in titles release starting in 2015. So this shows that Amazon adopted a highly aggressive strategy to grow its volume over last decade. And finally, the classic talent is prolific. So our talent analysis showed that the top actors and directors are predominantly from the classic Hollywood era of 1930s and 50s, which suggests Amazon has a very deep, unique catalog of older films competitors might lack. So based on these points, my final recommendation is for Amazon to now pivot from volume to quantity and to leverage that unique classic catalog and find its specific niche audience. So thank you for your time. Thank you.